This video we are going to discuss about autocorrelation property of DFT. So it connects the autocorrelation sequence of a signal to the magnitude squared of its DFT. So what it means is R of x e power j omega. That is nothing but it is so that is equal to summation R x of let me term this one as Rx of m e power minus j omega m. This ranges from minus infinity to infinity. So that is equal to modulus of x power e power j omega the whole square. Okay. So where this R of x of m, that is equal to, I can write this one as summation x of n minus x of n minus n. This n ranges from minus infinity to infinity. So how to prove this one? So I'm going to substitute this above equation in this equation. So this is what the statement, okay, and we need to prove this one. So the proof is Rx of e power j omega, that is equal to summation m is equal to minus infinity to infinity. Instead of Rx of m, we are going to substitute x of n into x of n minus m, where n ranges from minus infinity to infinity, e power minus j omega l. Okay. So how to prove this one? Here you can see this is a convolution property, right? So this has to be x of n into convolution of x of minus n. So this is a autocorrelation term. Okay. So here I am going to take u is equal to n minus m. Okay. So where n is equal to u plus m. Right. So from this one I can write m is equal to n minus c. Right. So if n value is equal to minus infinity and n is equal to infinity, what will be the u value if I substitute in this equation? That is minus infinity and infinity. So I can write this equation as m is equal to minus infinity to infinity summation x of n x complex conjugate of u. Okay. So this must be e power minus, instead of m I am going to substitute j into j omega n minus c. Okay. So you have n term which is from minus infinity to infinity. Okay. So if m is equal to minus infinity to infinity, what is u? So u is plus infinity to minus infinity, right? So I can write the sum term, right? So the u is equal to minus infinity to infinity. Okay. So this I can write it as summation of n is equal to minus infinity to infinity x of n e power minus j omega n. And again I can write u is equal to minus infinity to infinity x complex conjugate of u e power j omega u. Right. So I can write this one as x of e power j omega, where this one is x of x complex conjugate of e power j omega. Right. So where x star of e power j omega complex conjugate of e power j omega is summation u is equal to minus infinity to infinity x of x complex conjugate of u e power j omega u. So this is equal to x of e power j omega whole square. So hence it is true. So the next property is linearity. Okay. So DTFT of a into x1 of n plus b into x2 of n is equal to a into x1 of e power j omega plus b into x2 of e power j omega. So this is what we need to prove. So the proof is Fourier of a into x1 of n plus b into x2 of n is equal to, so you know the formula, right? N is equal to minus equal to infinity. Instead of x of n, I'm going to substitute a x1 of n plus b x2 of n into e power minus j omega n. Right? So this I can write it as summation n is equal to minus infinity to infinity a x1 of n e power minus j omega n plus summation n is equal to minus infinity to infinity v x2 of n e power minus j omega n. So this I can write it as a into x of x1 of e power j omega plus b into x2 of e power j omega. So if answer is put.